Okay, so welcome to this talk about integration testing. First, a little word of introduction, even if nobody cares, it's just for me, by the way. So I'm Nicolas Frankel. I'm a developer, an architect, I'm a consultant, I'm whatever the customer asks me to do. I've been working since 15 years in the software industry. I'm mainly focused on Java. And now I'm working for Hybris, which is a company that has been acquired by SAP, and we do e-commerce shop. So if you're interested. I used to do this talk a lot because 2 years ago I wrote a book about integration testing, and I added some new stuff. So even if you attended this talk before, perhaps you will find interesting stuff anyway. Before diving into the meat of the subject, let's introduce it. And you know that there are many forms of testing. Like you probably know about unit testing, perhaps about mutation testing, integration testing, performance testing, security testing. And inside everything, you have different kinds, like performance testing. You might have endurance testing, crash test, and so on and so forth. In this talk, I will mainly be focused on the difference between unit and integration testing, because I assume that most of you do unit testing. Who doesn't write unit tests? Yeah, nobody there. Oh, someone dared. Good. You are brave. So, unit testing is testing a unit, and a unit is generally a class in isolation. While when you do integration testing, you are testing the collaboration of those units or those classes. In order to get very pragmatic, let's take the example of a prototype car. Cars are a very good example in software. So unit testing in that case would be the same as testing every little piece of the car separately. Every nut and bolt, you test it, you measure it, it's good, it passes the test. And integration testing is like having the car, the prototype, assembled, and using it on a circuit that it performs well. And I'm very cautious because some people say, yeah, you know, you should do unit testing and integration testing. It's bonus, but it's not worth it. And other people say, yeah, you're not sure of anything until you've done integration testing. Unit testing is just time wasting. Both are completely wrong. Because if you take my example of the prototype car, I mean, would you be so stupid to take the car on a test drive without having tested every piece separately? It would cost much too much. And on the contrary, would you just mass manufacture the car without any test drive? Makes no sense in either case. So don't listen to those kind of people that oppose them. You have to do both unit testing and integration testing. Both are mandatory. Only with unit testing, you don't know if the software is fit enough. And only with integration testing, well, I will talk about it later, but you will run into problems. A new concept that appears when you do integration testing is the concept of the system under test. So what gets tested? When you do unit testing, the scope, the system under test, is a class. So there is no discussion. When you do integration testing, you can test the collaboration of two classes. So it's a very limited system under test. Or you can test the whole software. And then the scope is very big. So this is the first thing that you need to define when you do an integration test, is to define the scope of the system and the test. And you can reuse, if the system and the test is not the whole software, you can reuse the lesson you learned from unit testing. You can use dependency injection, you can use test doubles, mocks, and stubs, and so on. So this is just a reminder that you can use every test double you have, the dummies, mocks, stubs, spy, mocks, fakes, whatever. It is very tempting when you discover integration testing to test everything, to test the whole software in itself. I just want to remind you that testing is not about having the biggest code coverage. It's about return over investment. By testing your software, you make the bet that the time you invest in your tests will be lower than the time you will be spending otherwise debugging it or creating issues and fixing bugs and so on and so forth. So it's not a contest about the biggest coverage. It's really in order not to waste any money. So back to integration testing. The larger the system and the test, so if it encompasses the whole application, the more fragile your test will be. So you have to think about it before creating those kind of tests. That's why, generally speaking, it is a good practice to have a lot of unit tests, and then you create integration tests that are small in scope, that you might want to test a collaboration or 2 or 3 classes, and you create less of them. And the bigger the scope of your integration tests, the less the number of tests you have. And of course, when you are at the bottom of the so-called testing pyramid, you test everything, you create exceptions, you test exceptions, you test for every possible configuration. And at the top, you only test for nominal cases. Like, for example, if I have an e-commerce shop, my integration test that encompasses the whole application will check that, can I browse the catalog? Can I put one item of the catalog in my basket? Can I go to checkout? Can I pay down? Or perhaps can I register before? But very simple, the nominal case. And of course, with integration testing, you've got new challenges. It wouldn't be fun otherwise. The people who said that you shouldn't integration test generally cite those 3 big problems of integration testing. And those are real problems. The first stuff is those are very slow. Like, normally, if you run unit tests, the build should be less than 2-3 minutes. I mean, developer shouldn't have a chance to get the coffee, right? That should be the time for unit testing. You want very quick feedback. With integration testing, it's hard. They got very slow. Integration testing are fragile. It's very easy to create many integration tests with Selenium, for example, and end-to-end testing is like the testing the whole app. So it's a kind of integration test. You can create many tests very easily using the Selenium IDE inside Firefox. And then they will break. And so it's easy to create them, and it's much time consuming to maintain them. So they are very fragile. This is a problem. And when they break, you have to diagnose what happened, what broke. That also can be an issue. So how can we address those problems? Why are they slow? Because they start relying on real stuff. Like they start relying on a database. They start relying on a web service. They start relying on starting up Tomcat. So how do we cope with that? It's hard to cope because we cannot say, hey, Tomcat, start faster. We cannot say, hey, to the web service, hey, go faster, man. It's very hard. So the first step is to separate between unit tests and integration tests. Because taking, again, my example of the prototype car, I mean, it makes no sense to launch the car on the test circuit without first having checked every piece. So let's first launch the unit test. If the unit test fails, then it's no use wasting time for integration tests. So fail fast. This is a lesson. Fail fast. And how is it achieved? Well, it depends on the build tool. Who here is using Ant? Life sucks, yeah? I know. Who here is using Maven? Yeah. And who are the hype nerds who are using Gradle? This is a door. I don't want to see you there anyway. No, okay. By the way, Gradle, I will talk about Maven, but Gradle doesn't know about integration tests. It doesn't know. You have to hack it yourself. So it's possible, but I should. So this will be focused on Maven. Sorry for the other guys or girls. So this is a Maven lifecycle. And of course, you compile, you test your integration test. Maven, like all those years ago, it's not Gradle, but they thought about integration testing. Yeah? So in every phase, you have some plugin which is bound to the phase. And who can tell me what's the name of the Maven plugin that executes unit tests? Yeah, good, 1 point. I don't have any beer tokens, sorry. Perhaps next year. This is Surefire, and Surefire is implicitly bound to the test phase. And by default, it will run any test that ends with test, that starts with test, or that ends with test case. And the guy who created the other plugin, which is called Failsafe, just copy-pasted Surefire and provided another nice name called Failsafe. And by default, Failsafe, we do the same, but with test classes ending with IT, starting with IT, or ending with IT case. So this is really copy-paste, do the same. However, you saw that with unit testing, it's easy, you have only one phase. With integration test, you have 4 phases. You can do something before the whole integration test suite. You can do something after the integration test suite. You can do something during, of course. Probably you will launch a test. And then afterwards, you have the verify phase, which basically breaks your build if something happened during any one of those phases. The biggest difference is that you have to bind it explicitly in your POM. By default, it's not activated, so you can do like MVN integration test and see nothing, which sucks. So you just have to add those lines, and you say stupidly, I will bind the integration test target to the integration test phase, and the verify target to the verify phase. And of course, if you need also pre and post stuff, you can do it here. I never use them, but you have to know they exist because you might run into a use case which require them. So how does it translate into continuous integration? Well, unit testing still run at every build, like on your machine, and at every commit also. And integration tests, because they take more time and you cannot wait for the feedback, should have dedicated builds in Jenkins, in Bamboo, in whatever, and then you can run them hourly or daily. So that means you don't have immediate feedback, but is it better to have a later feedback or no feedback at all? It's up to you to decide, but I have my idea, right? So problem one, not solved, but addressed, slow. We cope with slowness by having separate stuff from for unit and integration tests. Second problem, they are fragile because they depend on stuff that are outside our scope. Do you handle the database stuff? No, those are DBAs. Do you handle the web service or some external providers? No. So that is very hard to handle. And when you think about it, there are many external resources that you depend on. Of course, database, perhaps web service, mostly more and more web services. But sometimes most of the time, you also depend on the file system. Sometimes you have applications that fail because the file system is full. So you should have the file system. If you write on a shared folder, your log, for example, it must be accessible. If you want to run batches that are scheduled, you need the time resource. You need the system clock. You need mail servers, FTP servers, perhaps MQ series or Hornet MQ or whatever. So you need a lot of infrastructure stuff, and that is very hard to integration test those. So we will only take a few samples. The first, time and file system. With time, it's very hard, especially if inside your batch you say new date. It's very hard to test this kind of stuff. So in that case, just use dependency injection and inject the date in the constructor. And then you can inject any date you want and check that your class behaves according to the date that you injected. For the file system, I recommend using the new Java NIO file path instead of the old one, JavaUtil.file, because path is an interface, so it's easy to mark. Database is an interesting problem. Basically, if you want just to test the service layer, we can mock the repository layer, the data access object layer. But if we want to test the data access object, shall we mock the database? So when I make this request, you send me this stuff. But in that case, you don't test anything. I mean, so that's a real problem. In that case, you shouldn't use mock. You should use fakes. So fakes are different from mocks. Fakes already are implementation. They are default implementation that most of the time doesn't make sense suitable for production use, but they have real behavior. Who here is using Oracle? Okay, so half of the room. Okay, I will take this example because it's generally the most widespread. Of course, now coming with NoSQL database, it's getting more and more fragmented again, but anyway. Basically, if you want to use Oracle database in your integration test, you have three options. The first option is to use another database, like MySQL, a free one. You don't care about it. And you hope that there won't be any gap between the fake one and the Oracle one. The second option is to use Oracle Express, or perhaps they rebranded it. So not the real Oracle database, but something which is closer, and still you will hope you won't have any gaps. The third option is for everyone to have a dedicated schema in the real Oracle database. It all depends, because Of course, the closer you are to the real infrastructure, the less risk you have. But of course, it requires more setup. I mean, you have to call your DBAs, if you are not DevOps, and ask them to create schema for every developer. And you also have to hack something. Like, for example, at some point in time, I looked at the name of the logged in user. I translated to the name of the schema, and I use this schema automatically in a property file. And that works pretty well, but the setup was every developer had to add a dedicated schema for him to run his integration test. So it depends on your organization. When you don't have so close relationship to your DBA, or they don't want to give you the schema, or it takes ages, generally, you use an in-memory database. And the good thing is that they run pretty fast, and they are 100% reliable. Lastly, I use H2. So H2 is the descendants, the child of HSQLDB, and it has a so close compatibility modes to Oracle, which still you might expect a gap, but a smaller gap. And the good thing is you can set up everything inside of your project. You are dependent of no one. And so you have no fragility. So if you have money, if you enjoy a good relationship with your DBA, and you want no gap between your integration tests and your production tests, have a single dedicated schema for every developer. If you don't have this, or are ready to assume the risk, then use H2. Another problem that we run more and more often into is web services. Web services, because your application might consume web services. You might be dependent on web services. This is a so-called infrastructure resource dependency that you have in your app. How do we cope with that? Of course, we can fragment it into, do we host it already, or is it third party? In most cases, it doesn't play any role, because even if you host it yourself, it's not your own department. Probably it's another department that doesn't want so much to help you, but has other objectives. So it's better to segment it into, is it REST or RESTful, or is it SOAP? And we use the same stuff as for database. We use fakes. So you might know about the Spark Java micro web framework. Who knows about Spark? Quite good, like a few hands. It's very simple stuff. Probably it's only for your own project. It's probably not for real enterprise stuff. However, it works super well for integration testing. Let me show you a few lines of Spark. And basically, you set the port, and you say that when you use a GET request on hello, then it will return a string. Of course, it is using Java 8. Anybody here is troubled with Java 8 syntax, or no? Okay. Oleg, Pibier, Boudiet, Pipiet. That was not a joke. So nobody is troubled by Java 8 semantics, right? So, and this is the kind of stuff that you can use. Also, you can use parameters that are sent in your integration test. And also, you can set HTTP status if you want to say, no, I want to check how my application behaves when I'm not authorized, by the way. So this is the kind of stuff that you can hack very easily. And if you want to return a JSON file, you just create the JSON file beforehand and serve it statically from here. So just in a few lines of code, you can create your fake server and let it handle your codes. Now comes a real problem. Who is still using SOAP stuff? Who is a consumer of SOAP services? And quite a few, and also all. So I'm sorry for you first. You could use the same methodology, but basically that would mean creating a lot of big XML files that are harder to craft by hand. And in that case, it will drastically reduce the return over investment. So perhaps there is something to do with SOAP UI, because testers use SOAP UI to test the web services, and we can create it in the GUI. The advantages of SOAP UI is that, yeah, it has a GUI, so anybody can use it. It has pretty good documentation, it has support, it understands pretty much everything that is around SOAP. And how would you use it? Well, first you would get the so-called web service definition language file, you know, this big file that nobody understands. And then you would create the mock service and say, hey, when I call that, I want to return it and stuff. The problem with that is that we are doing automation testing. We want it automated, so that's crazy. I don't want to use a GUI. Yes, but what not many people know is that there is an API around it. Of course, it's a little verbose, but it's still available. And of course, you didn't choose to work with SOAP technologies, so you have to make it the best out of the way. So this is a way that you would create programmatically the FAQ server and the FAQ response. Of course, I don't expect you to describe everything right now, but just know that there is an API. Once you get the WSDL, you can get the SOAP UI jar as Maven dependency, as a normal Maven dependency, and start doing that for real. It requires more effort, but again, it's SOAP. I have some advices for doing this kind of stuff. Those are general advices, not only for web service, but sometimes you start trying to be smart integration test, trying to factorize code like you would do in normal code, like, oh, but I repeated twice the same line, so I will have a common method and stuff like that. I would recommend not doing that for tests, because generally tests are like a kind of specifications, and I like my specifications to be able, I should be able to read it very easily in one page. So if you start to create components and to be smart about it, it will be harder to understand, and then you will need to have tests to understand your test, and anyway, it never stops, right? So try to be very, very, very stupid and lazy. So those are the kind of dependency that we have for integration tests, but we forgot about the biggest dependency. What is the biggest dependency we forgot so far? Probably you run in containers. It can be Tomcat, it can be Spring, it can be Spring in Tomcat. But those are containers, and you cannot say that you run your car on a circuit without having tested the deployment, the real stuff. So, since I've heard that not many of you do proper Java EE, I will focus on Spring. Was I advised wrong? Who does really pure Java EE without Spring here? You again. Yeah, you were the only one, I'm sorry. Okay, so I would advise nicely. Thank you. It's possible to do also. There is something available for Java EE, but will come to me afterwards and we can discuss. So now we can mock everything. We can mock the beans, like I have a service bean and I can mock the repository bean that it depends on. I can fake the infrastructure dependency, like I have a repository and I want to test its interaction with the database, so I can set up very easily an H2 database instance. But what didn't I test so far? The configuration. And it's like everything. You cannot test configuration like that. You have to provide for a configuration that is testable. And I've seen so many times, like one Spring application, 2,000 lines of XML file, very hard to test, very, very hard to test. So configuration, it's like normal codes. Even more true if you're using Java configuration. It shouldn't be monolithic. It should be like little pieces that every piece has a responsibility. So now we will design such sets of beans, and each set can contain either real beans or fake beans, and we can replace them. Very simple example. You need to use a GNDI data source. That is the most common use case, right? So you have a service bean that depends on a repository bean. The repository bean depends on the data source bean, and the data source is taken from GNDI, right? So instead of putting everything into the same file, you will break down the file into two files. The first file is about the service repository, and the repository, you only say it depends on this data source, which has an ID. You don't define the data source in this file. You define the data source into its own dedicated file, right? And now you can have a file that defines a data source that points to the real Oracle database, or that goes through GNDI, or you can define, for testing purpose, one that points to an H2 instance database. Using the latest Java config with not XML, but the admin annotation, this goes like this. First, you have the GNDI data source lookup, which will go into one file. And the other, which is slightly more verbose, directly use a so-called data source from Tomcat, if you are using Tomcat, which I assume, and uses H2. Just put this line into your mind. I will come back to it later. Set max active. So this is a structure that it gives us. You've got the main configuration and the data source config. And then you've got the test data source config in SRC.test. And depending on whether you are in test or in your real configuration, you will assemble the fragments that you need. So for example, in production, you will say, I will need data source config and main config. And in your test, you will say, I will need main config and test data source config. Done. And Spring will take care of assembling everything. So several tips around that. Those tips are based on my experience. I've done pretty stupid stuff before, so don't do them. The first stuff is don't reference fragments inside fragments. Don't say my fragment depends on this fragment and so on. This is to the top level container, whether be it the application or the test class, to say I need this fragment and this fragment. So it should know the way to assemble them. Remember the max active parameter? Do you know about data pool exhaustion? Do you know about it? You know the data pool, so you have got a number of connection, and you take one, but just afterwards you have to put it back in the pool. Otherwise, after some point, if you take more eggs, then you put them back, what happens? No more eggs. And then the next guy who wants an egg has to wait until the timeout. It doesn't work. This sets the number of eggs in the basket to 1. And that you want to check during testing. So you can already know if every one of your developer remember to put the connection back into the pool. You don't want to wait until production to see that. And of course, my latest advice is use Java config. This is not related to integration testing, but about Spring in general. Forget about XML, forget about self-annotating classes, use Java config. Okay, but now how do we test? How can we test? Well, there is a module for that in Spring called Spring Test, very easily. And it's integrated with TestNG, it's integrated with JUnit. So, how does it work? You will tell Spring, I want to use this configuration class or this configuration file, so those configuration fragments, in a context configuration stuff. You have your usual run with stuff. So here you have a Spring JUnit for class runner. If you want to use TestNG, you can extend the TestNG runner. That works also quite well. And this runner knows how to inject your dependency that you will need in your test, like either to call methods or perhaps to do some assertions. And it's done. You don't need more. The dependency and this kind of stuff, nothing else. Now you might want to test with the database. Of course, you set up the H2 database. You want to test transactions. Developers love transactions, especially when you are junior. When you are more experienced, you understand there is nothing mind-blowing about a transaction, but first you are very, very afraid. So normally, you put your transactional boundary in the service layer with a transactional annotation, right? Hey, there is a little funny stuff about Spring Test, is that by default, it will roll back everything after the test. Probably because it was designed at the time where there was one single database and you didn't want to pollute the state of the database. However, when shit happens, when a test fails, you want to know what is in the database. You want to audit the state. Where was I? What happened? So you want to commit your changes. You want to commit your transaction, even if they fail. And for that, there is an annotation, commit. So just tell Spring @commit. Otherwise, it will roll back your transaction by default. Now, it might happen yet that you still want some test to roll back your transaction. There is an annotation for that called rollback. So here, this will be committed because the class is annotated with commit, and the first will be rollback because, of course, it's annotated with rollback. So this is very simple to forget. By default, Spring rollbacks transactions during tests. If you don't want that, put commit. So I told about end-to-end testing. It's so easy to do, but it's so fragile because the UI changed a lot during the course of the project. Of course, you have the patch pattern and stuff that like downtones the problem, but still, it's not so fun. However, what generally is very stable is the URL. The URL is very stable. What does Spring provide us? Something to test at the controller level, but not at the class level, at the URL level. For example, this is an example of Spring mock MVC usage. You somehow obtain a mock MVC instance, and you say, call using get / and then you have expectation assertions, and you say, I want that the status be 200, and I want that the view it returns should be named welcome. So you are completely forgetting whether it's a GSP and it's welcome.gsp or a free marker template or something. You just are interested about the view. So in that case, you're testing down to the database, and then back, and then forgetting about the UI, which again is fragile. So you want things to make things more stable. I will finish by talking about Spring Boot. Who is not using Spring Boot? Yeah, I understand. So I'm not using Spring Boot. I should. I do a lot on my own, in my personal life, but not in my business life. So Spring Boot, for those that don't know Spring Boot, this is a Spring framework. It gives you everything, but then it's up to you, right? And the people who had to set up a Spring project from scratch know the pain it is. Like when I did that, I told the developer to read the documentation, and I did all craft the POM myself. Took me 1 day. Nobody touched it meanwhile. It's interesting, but it's always the same stuff, right? A Spring Boot is already configured for you, but with like defaults, like good defaults. And you can override everything. And well, you just download the Spring Boot POM and it's done. And with Spring Boot, you've got an annotation for that. You've got an annotation for everything, right? You've got an annotation to get the mock MVC stuff I talk about injected for you automatically. Also, with Spring Boot, you can use Spring Boot test instead of application context, and it will magically scan the class path for all your configuration and self-annotated classes. It also brings you something I don't like so much, but well, you can't always have everything, is you can test by layer. Not by lasagna layer, like in the picture, but by architectural layer. So for example, you can test only your controllers, and by annotating the services as dependency in the test with mock bean, then the web MVC test will say, hey, okay, I will need to use these mock beans and provide Mockito dependency for them. And then you will stop at the web layer. On the opposite side, you can use the same stuff with data GPA test to say, okay, I will have an H2 instance database automatically configured for that. So you can really test layer by layer, which is not really unit testing, but the start of integration testing. However, it doesn't help you with testing like a slice. Perhaps I might have a small demo. I have, how many minutes do I have left? 5? 4 minutes. Okay, so this is the Spring Pet Clinic. Hey guys, where is my screen? Okay. I will exit the show, perhaps it will be better. Yes. So, and nobody told me anything, I had to look myself. So this is a Spring Pet Clinic, very simple stuff. You get the home, you can search for an owner. Of course, it has not been found. If you want to search for every owner, then it will get you every owner. You can get the veterinarians, and of course, you check that when you click on that, you quote the exception, right? And basically, the code is there. So here, I wanted to show you how you could do such a test. Like that. So I told you about the run with. Here is a runner. I told you about the Spring Boot test, and here I want to specify that the class on the test is a welcome controller. And as I said, I want to use the mock MVC stuff. And in previous editions, you had to create the mock MVC yourself with mock MVC builder, and it was super painful and blah, blah, blah. And now you've got this annotation. I love it. You just say auto-configure mock MVC, you provide it, you say it's auto-wired, and you've got it done. And here, it's exactly what I showed you. mock MVC, perform get, and expect status is okay, and expect view name welcome. So this is fluent DSL for testing, right? And if I run this test, probably it will work. I hope so, at least. Yes, so it's good. And you see here that well, it's very small, but the people who are in front and didn't choose to slack off in the background can see that you have a lot of debugging information about the headers and stuff. Here, is it a real integration test? Well, depends, because you don't know about the welcome controller. It is a welcome controller. Now, it is an integration test. Why? Because it uses Spring. It uses a Spring controller. This code is useless without a controller that understands the controller annotation and the request mapping annotation. So this is an integration test. This is the first step of an integration test of a controller. But it's not super interesting. I mean, the probability of having bugs in that kind of stuff is very low. However, we can do better. Let's see that I showed you about the owner. So we might want to search for owners, right? And then searching for owner gets down to the database, right? So this, we want to test the whole slice. And in that case, we will say, okay, I want to check for owner. And the database is already set up, so that's good. And I'm checking that when I search for owner like 10, then I should have something in the model. That's a little more subtle. I should have my model that is filled. And it should have a property which is ID, and the ID of the stuff that is in the model should be 10. And the last name should be to Esteban. So this is the kind of stuff that you can do integration testing with. And all thanks to Spring Boot. So if you are using Spring Boot, I advise you to use that. If you are not using Spring Boot, I advise you to use Spring Boot. So that's all. You can, of course, read my blog. You can follow me on Twitter, or you can become my friend on LinkedIn. And of course, you can purchase my book. And there are still some time. If you have questions, already a question. Yes, please. No, the guy here. He wants to. You forgot the mic.
Thank you for a good talk. I have two questions. First question is, there are two approaches in automation testing. First approach is writing test first, then code. And second approach is writing code first, then tests. Which approach would you support? And second question is, there are a project where requirements are changing very quickly. So developers have to do double work, changing code and tests. Which solution would you recommend in that case? Thank you.
Okay, so about the first question, should you first test or first code? I'm not an advocate of TDD. I'm sorry. I tried it, didn't work so well. The thing is, for me, you do TDD to have a better testable design. So if you already code in a testable way, for me, it's not so useful. And if you are doing Agile should say at any point you can stop and deliver something. Now, if you have written all your tests, what will you deliver? So I'm not super trendy by doing that, but I mean, I always write the code first. It's not basically what I advise you to do, but that's how I work. That's the first one. And about your second question, asking, you are in a very changing environment. Sorry for you first. And the second is, remember that testing is about return over investment. So if you do a lot of tests, and every change you have to throw the test away? Is it time wasting or is it an investment? I cannot answer for you. It depends on the context. But from what I infer, you might not want to have such a high code coverage and such a big test harness as I would recommend, because otherwise it's just waste. And you don't want waste. So be pragmatic in that case. And of course, you never tell your colleague that you only have 10% code coverage, because it doesn't look very good on your resume, but be pragmatic, you don't care. Other questions? Yes.
Nicolas, first of all, thanks a lot for coming to Kharkiv. Thanks a lot for your speech.
Yeah, it's super far away, by the way. Huh?
Yeah, well.
Kharkiv, you could put Kharkiv like more west for me, please. Next time.
Yeah, next time. Rostov. Давай Rostov. And so I wanted to get your opinion on behavior-driven development, much like Serenity or what used to be called Thucydides.
Yeah, this is outside the scope of this talk, right? This is outside the scope of this talk. But I've tried, not by doing behavior-driven development, but by doing, like, again, first code, then test. It's nice if you have a lot of collaboration with the business people. If it's only for you, not so much. It's good if your testers are not very technical and they don't do automation. They don't understand or don't want to understand the code. Then you put like a layer of BDD, of like Cucumber or stuff like that on top of your test, and then you can interact nicely with them. Again, if it's not the case, it's just like time wasting. So it depends on your context. But yeah, it works, but it's a lot of investment. I mean, creating the Cucumber layer, you have to use a Gherkin file, you have to really like bind the stuff together, you have to maintain the test. Remember that when something changes, you have to maintain everything to keep it green, so it's a lot of investment. It's only worthwhile if you interact with a lot of business people that needs to use them. Like, oh, I will change the specification, so instead of updating the documentation, I will change the Gherkin file, then you will have a failing test, then you will come to the guy and say, hey, what do you want? And okay, it's not clear enough in your scenario, then it works. But I have very little experience with that.
I have a question. Thank you. First, thank you very much for your guest talk. And my question is, will FileSafe work with Suffice or any other older infrastructures, for example, code analysis or coverage or mutation, for example? Will it work with old infrastructure? If
I am using Sonar?
The FileSafe plugin. Yes.
The FileSafe? Yeah. You, if you are using SonarQube, there is an optional widget that gets you the integration testing coverage separated from unit testing coverage. So there is something in the documentation you can look at that, yeah. But I mean, integration testing coverage, as I said, the higher you get on the top of the pyramid, you shouldn't test for everything, so it's less interesting than unit testing. And even unit testing code coverage for me is just bullshit. And I advise you to check my token mutation testing if you want to know why. You had a question, yeah?
Yes, and may I interrupt you? Sorry. Can we have two last questions here?
Two last questions.
Yes.
Afterwards.
And if more, then could you please just ask in person, because we need to switch the speaker and make some preparations, and we are running out of time.
Bistra.
Yes, if possible.
Test in G vs JUnit for integration testing is.
So I was thinking about that for my next blog article. Basically, it's about test ordering, method test ordering, right? Many people are saying, yeah, test methods, they should run in any order because you don't want to be dependent. for unit testing, it makes sense. And well, I have example where it didn't make so much sense. But let's say that I want to do an integration test for a checkout, for an e-commerce checkout. That is my usual example. And so first, I want to be able to browse the catalog, and then I should be able to put an item in my basket, and then I should be able to see the checkout page, choose my payment method, pay, and I will get delivered. So I will have one gigantic method, right? Now imagine there is a failure in that, and you have to know where it failed. Good luck. You will have to read the stack trace. Not so fun. Now imagine you can, what anyone would do is to cut those little methods, to cut this big method into small methods and make them dependent on each other, which makes sense. Now, if at any point in those steps the test fails, anyone, even a business user, can understand the name of the scenario or the name of the method where it failed. Like the catalog broke, hey, bye. Again, and if you have only one method like that, now if you have a tree, you can at any point say, all those children are dependent on this one. You don't want to test many different stuff where you put product into the basket if the catalog is not browsable. So fail fast. Does that answer your question? So method ordering is very important. In JUnit, no method ordering. TestNG, you can add method ordering. So for me, TestNG so far is very superior. But because JUnit was meant for unit testing.
Okay, are there questions left? No?
No question? Okay, thank you. Stop. One more question.
Yeah, the last one.
We've got in a trouble when some developers used JUnit and some used TestNG. And
Who is the architect?
Yeah, it was after some time we discovered that TestNG suppressed JUnit on CI and only TestNG tests are working, and JUnit just doing nothing. So, is there a way to solve such a maybe you
yeah. First is you should only use one testing framework. Okay. The second, as I said, for me, TestNG is superior. So you should migrate to TestNG. The good thing is that if you look on the TestNG website, they give you tools to migrate JUnit to TestNG with just command line. Oh, yeah. Хорошо? Okay, спасибо большое,
Yeah,
ребята.
okay, thank you.